Morning, my students. I'm going to teach you. Kindly mute. I'm going to take you through object-oriented programming, and I believe you will enjoy my lesson. So we shall begin by looking at the objective. What are we supposed to know at the end of the lesson? The first one, at the end of this lesson, you are expected to understand the concept of object-oriented and procedure programming, to differentiate between object-oriented programming and procedure programming, to outline 6 principles of object-oriented programming, to state 5 benefits of object-oriented programming. I'm hearing some echo, so allow me to modify as we continue. Now let's proceed. Now, since you've known what you are expected or what we are going to learn, let's go straight away and see the difference between the procedure-oriented programming and object-oriented programming. One, we begin by looking at procedure-oriented programming, where we say it is divided into small parts called function, while object-oriented programming program is divided into parts called objects. Now, we look at procedure-oriented programming is not given to data but to function as well as sequence of actions to be done, while the other one is given to the data rather than the procedure or function because it works as a real world. Now we say procedure programming follow top-down approach, while the other one follow the bottom-up approach. We also say that it does not have any access specifier, that is procedure-oriented programming, while the other one, the object-oriented programming, has access specifier, that is public, private, and protected. Now let's look at the last one. We say data can move freely from function to function in system, while the other one, objects can move and communicate with each other through member function. Now we are going to look at the principles or features of object-oriented programming. There are 6 of them. The first one is encapsulation, and when you talk about encapsulation, it means that wrapping the entities together. Now we also have data abstraction, polymorphism, inheritance, dynamic binding, and lastly message passing. We shall look at each of them in details and make sure you understand how it works. So we shall begin by looking at encapsulation. What do we mean when we say encapsulate? Is to wrap data and function together so as it can form a single unit, and this one we call it encapsulation. By default, data is not accessible to outside world, and they are only accessible through functions which are wrapped in a class. We have data abstraction, now which is the act of representing essential features without including background details or explanation. This is where you exclude the unnecessary coding or features, and you only include what is necessary. That is what we call data abstraction. We go straight away to polymorphism, and we say a polymorphism comes from Greek words poly and morphism, poly, which means many, and morphism means form, i.e. many forms, and polymorphism means the ability to take more than one form, to change under prevailing condition. Now, for example, an operation have different behavior in different instances. The behavior depends upon the type of data used in operation. Now, let's look at inheritance. And we say inheritance is ability of a new object to acquire behavior or characteristics or traits of another object. Inheritance is most programming concept of object-oriented programming, which help realize the goal of constructing software from reusable parts rather than hand coding every system from the scratch. Inheritance not only support reuse across the system, but also directly facilitate extensibility within a system. And we look at also the last two of them, which is dynamic binding and message passing. When we talk about dynamic binding, we mean linking procedure call to the code to be executed in response to call. While message passing, this is where the object communicate with each other. You find that in object-oriented programming, the objects communicate with the other objects. Now, we go straight away after now identifying the 6 features of object-oriented programming, where we say object-oriented programming is natural in nature. It does exactly what is happening in nature. It does reusability, inheritance, polymorphism, abstraction, and many others. So we want to look at what are the importance. Why do we need to embrace object-oriented programming? We begin by looking at reusability. And we say in object-oriented programming, it allows functions and modules that are written by different users to be reused again. You don't need to start from zero. Now we look at also inheritance, and we say through this we can eliminate redundant code and extend the use of existing classes. Number 3 is that reduce complexity of a problem. You find that a problem is divided into parts or objects, so that in case you had a problem in one, you can easily trace where the problem is and you can solve without any difficulties. Then we have easy to maintain and upgrade. Now it is object-oriented make it easy to maintain and modify existing code, as new object can be created with a small difference to the existing one. You can identify a very good program which is running, and then you just twist or modify according to your specification. And then remember what we learn also about message passing. We say that the objects communicate, which make it interesting when we are dealing with object-oriented programming. And lastly, modifiability. It is easy to make minor changes in the data representation or the procedures in object program. Changes inside a class do not affect any other parts of a program, since the only public interface that extends the wall as to a class is through the use of methods. Now I have assignment for you. I expect you to do it and submit it before our next class. I expect you to outline ways in which the principles of object-oriented programming can be implemented. Then we want us to go straight away to summarize what we've learned today. Remember, we've introduced about object-oriented programming, and we've said is a programming model that organizes software design around data or object rather than function and logics. Remember also the 6 features that we've discussed, that is encapsulation, data abstraction, polymorphism, inheritance, dynamic binding, and message passing. Thank you and have a blessed day. See you in our next class.
I have a question.
Yes,
I didn't understand about dynamic.
the dynamic. Now, thank you for that. Dynamic, we say mean linking of procedures or call to code to be executed in a response to the call. We We say dynamic binding or late binding means the code associated with a given procedure call is not known until the time of call or a runtime. When we talk about dynamic, we mean something that is running at that time. The program does not recognize that code that you are doing unless you call the object you want to link together. When you call that, we call it runtime. Hope it is now clear. Any other question?
No question, sir.
Thank you.
We are satisfied, sir.
Okay, thank you, and have a blessed day.